Okay, on page 6, this is 2.3, solving quadratics. So in there where it says topic, you can write 2.3. As soon as I get out of the way, you can. Solving quadratics. So now we're going to factor and then actually solve for the x value. So it gives you some steps here, which is super nice. Number 1, move all the terms to one side and set the equation equal to 0. So the big thing here is that your equation needs to be equal to 0. So on some of them, yep, on the first couple it is. The second thing to do is to factor. So if you need your chart, look at your chart that we did at the beginning of class today. Okay, the third thing is to set each factor equal to 0 and solve for the x value. And then you write your answer as a solution set. If you look very closely at that solution set, those are not parentheses, those are brackets. Do you guys see it? It's like this. Those are brackets. If you use parentheses, you're talking about an xy point. But these are both answers for x, so it's going to be not an xy point, so we need to use brackets. All right, so on number 1, I love that Ryan already has, and Dalton, they have their factoring papers out just in case they're going to need it from Unit 1 packet, in case you need it. And so does Olivia. Excellent. Okay, the first thing we always look for is what? GCF. Is there GCF in number 1? Yes. Well, first of all, step number 1 says make sure it's equal to 0. Is it equal to 0? Okay, perfect. Step number 2 is to factor it. And we always check for a greatest common factor. They said the greatest common factor was x, so we're going to divide by x. When we divide by x, where does it go? Goes to the front, right? Which leaves me with x on the outside and then x plus 9 on the inside. We're going to set it equal to 0. Now, it says set each factor equal to 0 and solve. So what I like to do is this. I like to kind of cut this in half and say, those are my two factors. I have x as a factor and x plus 9 as a factor. So I'm going to set each of those equal to 0. So when I set x equal to 0, that x factor, there's not much more I can do with this x, right? It's already set equal to 0. There's nothing to solve there. So that we're going to leave that one as is. Then I'm going to set this x plus 9 equal to 0. How do we solve that for x? Subtract 9. Guys, I know you're tired. I know we've done a lot today. Keep going with me. We're almost there. We get x to be negative 9. That means our solutions are negative 9, 0. Done. And I want you to try it because the brackets mean something different. So try your solutions, do the best that you can. They're not going to be perfect. What does what mean? The brackets mean that it's equal to. So the solution means that those are the answers. Okay, what about number 2? Why don't you try number 2 on your own? Is it set equal to 0? Yes. Then we get a factor. Okay? Pick up your pencil, please. Think about what the first step in factoring always is. Okay? GCF. Okay, we're not going to think of it that way because it's going to get tricky in a minute. And if you think of it that way as just do the opposite, you're going to mess up and you're not going to get the right answer. I know. I'm undoing everything you've already been taught. Okay. No.
You were taught.
Yes. So we're dividing by 4x, right? X is going to be equal to 0. And x minus 2 is going to be equal to 0. So how do we solve the 4x equals 0? What do we do there? Good. Divide by 4, and 0 divided by anything is 0. Okay, and then I just add 2 over. Crystal, I would agree with you that here is what you're saying, you just change the sign, right? But the problem is when we start to have coefficients like 3x minus 18 equals 0, you don't just flip the sign, you have to do some work. So I don't want you to get in the habit of just flipping the sign and then you miss something, okay? X is 2, so we're going to write it in our brackets. Please try to keep in mind to write it in small to big, 0, 2. If you don't, it's not necessarily going to be wrong. I just want you to try to get in that habit. 0, 2 is your solution. All right, let's do a few more.
Wait, I have a question.
Yeah.
Does it matter, like the pair you wrote, does it matter how you write it? Like which one goes first?
Did you hear what I just said? Okay. I want you to write it smallest to biggest. So 0 is smaller than 2, so write 0, 2. If you do it the opposite way, it won't be wrong. I just want you to get in the habit of writing small to big. Okay?
It's easy for her to write. Also, if you saw it on a standardized test and it was multiple choice, that's the way it would be. So you want to, it's just going to be a bit
Consistent. Yes.
The first one, negative 9 is smaller than 0, so
Right.
never mind. I was about to correct you when it wasn't even
That's why negative 9 came first, because negative 9 is smaller in number 1, right? Okay, let's do number 4. So skip number 3, let's do number 4. Remember your process of factoring. Okay, so then it's 2 terms, and I'm going to look on that chart. What do I do if it's 2 terms?
Would this be a difference of squares?
No.
Actually, yeah.
Why don't you think to yourself while your classmates are also thinking to themselves? Where's your packet at? I know you think we take notes just to busy our time. Get your notes out and look at that page. What did you do when there are 2 terms? What does it say to do? That's 3 terms, right? That's why we put the 3 there. Okay.
It is squares.
So 9 is a perfect square, x squared is a perfect square, 25 is a perfect square. 1 has to be minus, 1 has to be plus. Set it equal to 0. Now what are we going to do with each of these? Split them and set them each equal to 0. So I just like to split them down the middle. 3x minus 5 equal to 0. 3x plus 5 equal to 0. Go ahead and solve. This is where you can't just flip the sign. What? You need to get rid of the number first. So you're going to add 5 first. Yes? So plus 5 plus 5. 3x equals 5. Divide by 3. Does 5 divide by 3? Okay, so 5/3 is one of my answers.
But I thought both answers would be 0.
When you plug 5/3 in for x here, it is going to equal 0. But the number that x is does not have to equal 0. When you plug it in and solve it out, yes, it has to equal 0. So we'll subtract 5 on this side, divide by 3, and I get x to be Negative 5/3. So remember when we write our answer? Negative 5/3, comma 5/3. That's going to be your final answer. Fractions are okay and will become very common, actually, in Algebra 2. All right? Let's try number 6. Look at your chart. What's the first thing you do when you're factoring?
Number 6.
Mm-hmm.
2.
Rhetorical question.
Oh.
Okay? So what two numbers multiply to get a negative 12 and add to get a negative 1? What numbers are you guys choosing? Negative 4 and 3. Good. Remember, because our x value, the coefficient of our x squared is 1, we can just take the shortcut. So I have x minus 4, x plus 3 equals 0, but I still have this 2.
Wait, where did you get negative 4 minus 3?
If you add negative 4 and positive 3 together, you get negative 1. If you multiply them, you get negative 12.
Where does negative 1 fall?
Okay, so now if we split these up, 2 is a factor, so 2 is going to get split up too. So when I set these equal to 0, if I set 2 equal to 0, that doesn't make sense, right? 2 doesn't equal 0. So this is actually gone because, look up here for just a second. If I divided this side by 2, it would cancel, right? What happens to 0 divided by 2? It's just 0, right? So your 2 kind of disappears. We can think of it like that, okay? So when you have just a constant, which is a number without a variable, it just disappears. So then you have x minus 4 equals 0, x plus 3 equals 0. So we get x to be 4, x to be negative 3. We'll write it in our fancy solution set. Okay, any questions on that one? All right, let's try number 8, please. It's set equal to 0. We always look for a greatest common factor. Is there a greatest common factor on number 8? No. All right. So now we go to the trinomial section of our little cheat sheet thing. When a is greater than 1, when there's a number there for a, Vinny, what do we have to do when we set up our x? If this number is not 1, what do we have to do? What two numbers am I multiplying? 6 and negative 4. Good. So I get negative 24. And they have to add to be 5. Okay, you know how to do this. Go ahead and factor. If you're watching the video, go ahead and press pause.
So now when I look at these first two, they have this. Now, do these two have the same common? No. This is a 3. Because 2 times x is not 6x squared. So that's
Okay, if you get finished, check with your neighbor and see if you guys got the same answer.
is the 4/3 geometry part of it.
Actually, it's supposed to be easier.
3x plus 4 times 2x minus 1. If I split that and set it equal to 0, this one becomes negative 4/3, and this becomes positive 1/2. Can we agree with that? You guys have already worked it out? I have one table that agrees with that?
Yeah.
Okay, good. Thank you, Miss Carolyn's table. All right, so we're going to write our solutions. Negative 4/3, 1/2. All right, let's look at a couple on page 7. We're not going to do a lot of them. We're just going to set them up. So go to page 7. Again, we're not going to do a lot of them. We're just going to talk about how you set them up, okay? So remember, you have to make sure that they're set equal to what? 0. So none of these on this page are set equal to 0. So if you look at, for example, let's look at number 10. If I wanted to set this equal to 0, what do I need to move? That x squared. And how do I move x squared over? Subtract it. All right, so if I subtract x squared, that just becomes 6x squared plus 8x equals 0. Can you combine x squared and x?
Oh, no, okay.
No.
No. I would got 7x squared.
I did. 7x squared minus 1x squared
Yeah, that's what
is
I was
6x squared.
asking.
Okay, yeah.
I was a little behind.
So now it's 2 terms, and now we go back to normal, right? Greatest common factor, pull that out, see if it's a difference of squares, and we keep going, just like we did on the previous page. Let's look at number 12. What do we need to move over? Okay, when the x squared is on the left side, you always want your x squared to stay positive. So even though the majority of the information and the terms are on the right side, we want to move it to the left side, because if I subtract 3x, I'm getting a negative 4x squared. You guys see that? We always want our x squared to stay positive. So let's add x squared over. Okay, so let's add x squared over. What's 3x squared plus 1x squared? 4x squared equals 81. Is it set equal to 0 yet? Guys, if I'm writing this down, you should be writing this down. So it's not equal to 0 yet, so what do we need to do with that 81? Subtract 81 over. So 4x squared, there's nowhere to combine the 81. So it just hangs out over here at the end. We set it equal to 0 now, because if we take 81 away, there's nothing over there. And now look, difference of squares, right? And then we would continue to factor like normal, like we have been. Okay? Let's look at 14. What are we going to do on 14 first? Just do things one at a time. Okay, let's subtract x over. On 14, let's go ahead and subtract our x over. I would put it under the 11, so you're putting it under the like terms. So I have x squared plus 10x plus 29 equals 4. We're still not set equal to 0. Mitchell?
Subtracted the x from the 11 now.
Yeah.
Why do you-
Because remember, 11x minus 1x is 10x,
Oh, okay.
right? Okay, who said what do I need to do next? Good, Dalton. I'm going to subtract 4 over. And I have x squared plus 10x plus 25. Now am I ready to factor? Okay, right? You can set up your x, find your factors, what two numbers multiply to get 25, add to get 10, and we go from there. What about 16? Why don't you try to set up 16? Set it equal to 0, as if you were going to factor it. Pick your pencil, please. Okay, so we're combining like terms. We're making this side 0. Nope, it's not like anything that we've done yet. So we're going to setting these things equal to 0. So can you write number 14, what I wrote up there? Can you write that on your paper, please? So this is an x, and we're moving it over, so I'm subtracting it under the other x term, because those are like terms. Which gives me 10x.
Yeah, that's the easy part.
Once you have set number 16 equal to 0, I want you to solve it. You can use the box in 15 to help you, to save some room. And x plus 3. Bring down your 4. Now is when we need to factor things out, right? Set them equal to 0. What did we say happens to that 4 out front? It kind of just drops out, right? Because 4 doesn't equal 0, and 0 divided by 4 is 0, so that's gone. So I have x plus 8 equals 0, and x plus 3 equals 0. So I get x to be negative 8, x to be negative 3. Which one is actually smaller? Which one is smaller? Negative 8. All right, it's farther down the number line than negative 3. Dalton was just checking to see if you guys are paying attention. Negative 8, negative 3. Okay? So, this is what we're doing tonight. Factoring and then solving. Okay? So if you flip over to homework page 8, it says homework 7 at the top, I think. You just need to do 1 through 10 on this page, please. 1 through 10.
It's basically the page, right?
Yeah. Well, the homework continues on to the next page, so I'm just having you do 1 through 10 on page 8 for tonight. Now, you also need to finish those 4 problems about writing the equation, right? Finding the A, plugging in H and K if you need to. So you need to finish those 4. And then today's lesson, those 10 problems.